So this is an oscillator problem. Part A asks when the maximum speed occurs, Vmax occurs when x equals 0. And of course v equals 0 when x is equal to the amplitude, right? When x is at its maximum value, it's like a max height problem. But we're at the equilibrium point. When we're passing through x equals 0, that's when all of the energy is kinetic and none of the energy is potential, okay? So we set 1/2 mv squared equal to the entire mechanical energy. And we leave out the 1/2 kx squared on the left-hand side. So if we solve for v, we get v is the square root of k over ma squared. And when we plug in the values given, that's 330 over 0.25 kilograms multiplied by 0.65 squared. That works out to be 24 meters per second. Now for part B, we want the kinetic energy equal the potential energy. So we want 1/2 mv squared to equal 1/2 kx squared. That works. So let me substitute. There's a little trick here. There's a couple of different ways we can go, okay? So we're trying to solve for x. One way to do that would be to say 1/2 kx squared is equal to 1/2 the total mechanical energy. Like that, right? And so the 1/2 goes away, and the k goes away, and then x is equal to the square root of 1/2 a. That's one way to do it. And that's a little tricky, but if the thing is, if the kinetic energy is equal to the potential energy, then that means each must equal 1/2 of the total energy, right? So that's a trick you can use. The other way, you can it takes a little longer, it's kind of a brute force way, but you can use the expression v squared is equal to k over m times a squared minus x squared. So if you do that, and we plug that in, we plug in right up here, we get 1/2 m times k over m a squared minus x squared is equal to 1/2 kx squared. Okay, and then the m cancels out, and this actually simplifies quite a bit to 1/2 ka squared minus 1/2 kx squared is equal to 1/2 kx squared, which gives you 1/2 ka squared is equal to kx squared. And therefore x, k goes away, is equal to the square root of 1/2 a. Or 0.707 a, which in this case is 0.46 meters. Okay, either one of those algebraic trick works to solve this problem.